In this video, we're going to explore z-scoring in a little bit more detail. Take the following problem. The first thing in computing a z-score is figuring out what the mean is and the standard deviation. So I did that work for you. I have a mean here of 81 with a standard deviation of 6.3. If you don't know what that means, you need to stop this video and go back and figure that out. You need to be able to calculate either a population mean or a sample mean and the standard deviation. So those are the first steps. I just did it for you. So basically what a z-score is it tells us where this value falls on our curve when we're looking at a normally distributed population. And then what we can do with the z-score is once we can put it on the curve, we can look at our z-score chart and look at the percentage of values that are below that number and the percentage that are higher. We'll do that in a later video. For this video, we're just going to look at where these scores fall on our curve when we're doing a normally distributed population. So let's look at our scores. We got a 65, an 83, a 93, and a 100. So we already know, because I told you, that our mean is 81 with a standard distribution of 6.3. So what we'll do here is I'll just kind of like put a bit of a curve on here. Now this isn't scientific. I'm using my mouse here. So we can say here that based on the empirical rule that we got 50% of our values are greater than 81 and 50% are less than. And let me put in my standard deviation lines that these are approximately 6.3 for a single deviation from the mean. So that would be, if we're looking at a specific number, that would be 87.3 would be one standard deviation above the mean. And if I look at a standard deviation below the mean, I'll just take 6.3 and subtract it from 81. And that gives me 74.7. And I'm just going to kind of rough in 2 standard deviations and 3 standard deviations. And what you can do is in your mind or in your notes, you can just add 6.3 or subtract 6.3 for each deviation depending on if we're above our mean or below our mean. So anyway, so how many standard deviations away is 65? Well, we could take a look here that 65 is below our mean, but where does it fall exactly? We can approximate just by looking at it and eyeballing it, but a z-score for sure gives us a better value and a more scientific way of computing that. So what we'll do here is first what we need to do is look to see how far away is 65 from our mean. Now remember, we're not really concerned if it's above or below, sort of. We just want to see how far away it is. And then what we do is we divide it by the standard deviation. So if we do this math, all we need to do is subtract 81 from 65 and then get the absolute value for that, which would be 16. And then we would just divide it by 6.3. So let's do that here. I'm just going to do 16, the absolute value, right? It's not negative 16, divided by 6.3. So it's 2.53 deviations from the mean. And since it's negative, right, that means it's below the mean. So we can say here that 65 is exactly 2.54 deviations below our mean. So what about 83? Simple. Well, we know what's closer, right? So we'll do 81, which is our mean, subtracted from 83, which is the score that we have. And then what we're going to do is we're going to divide it by 6.3, which is our deviation. So we know that the score is going to be a little bit above, right? Let me put A in here. A is like right there. And again, this is just kind of like me sketching here. So we know B is going to be right in this area here. It's going to be above our mean, right? It's 83. So it's going to be a positive number. So what we'll do is we'll subtract 83 from 81. We'll get 2 divided by 6.3. I'll do this slowly. Gives us 0.317. So basically, I'm just going to put this in here, that a score of 83 would be 0.32 above our mean. So it would sit on our curve just a little bit over the mean here right before one standard deviation, just a little bit to the right of our mean. Let's do the third score. The third score is 93. Now we can take a look at just our curve and say, well, 33 is above our mean, and it's way above it. So what we'll do is we'll subtract our mean from 93 and get 12 divided by 6.3, which is our standard deviation, and it'll give us how far it is above our mean. So we'll give this just a quick score, just a quick compute here, and we'll get 1 dot, I wrote this down at 9. So basically, it's 1.9 standard deviations above. So we can kind of mark that out. It's more than 1 standard deviation. It's almost 2. So it kind of sits there on our curve. Let's do one more. I'm trying to get you to think about the general idea here. Let's do one more. Let's just say we had like a 100. So we got D here. So I'm going to just kind of scroll up. And we'll do D is a score of 100. And we'll plug in the numbers, 100 minus 81 over our standard deviation, which is 6.3. So what do we get? Well, let's do the math really quick. You could use a calculator if you want, but this is going to be 19 over 6.3. And if we whip our calculator out, I'm going to do this right now. So we'll do 19, pardon me, there we go, 9 divided by 6.3. And we get 3.1 deviations above our mean. This is almost an outlier. Remember our empirical rule. So what we do now is since we've plotted these and we know where 2.54 is, pardon me, we know where 65 is, we know where 83 is, we know what 93 is, and we know where 100 is, we could see exactly where this fits on our curve. So that's the first step. It's actually, I mean, like I said, the first step is to get the mean and the standard deviation. So this is really the third step. The third step is find out where on the curve do these values fall. Because if we know that, we can go to the next step, which is determining the percentage of values that are above this number and the percentage that are behind. And that way we could put in our descriptive model and then make predictions based on what our z-scores are. More about that in an upcoming video. Thank you for listening. You should know more about z-scoring and how it fits in our curve. Thank you for watching. Have a great day.